Hello everyone, I am Dr. Navneet Kaur from Department of Computer Science and Engineering at SIRT College. Today I'll be discussing a topic from subject Computer Networks. The topic which I'll discuss here is flow control and error control. And under this topic, I'll discuss stop and wait ARQ protocol. Now, in this lecture, I'll cover concept of flow and error control, stop and wait protocol, stop and wait automatic repeat request protocol. Now, what is flow and error control? Now, the most important responsibility of the data link layer are flow control and error control. Collectively, these functions are known as data link control. Now, we can understand this concept from a real-time example. Now, every day we do online communication like online banking, online ticket booking. In this, there should be a communication between between the sender and the receiver. Now, for this communication to occur, there should be proper coordination between the sender and the receiver. This coordination is achieved through flow control and error control. Now, flow control refers to a set of procedures which is used to restrict the amount of data that the sender can send before waiting for an acknowledgement. Error control, it includes both error detection and error correction. It is implemented in the data link layer, which is based on automatic repeat request, which is the retransmission of the data. Now, data link control protocols, they are categorized into two groups. First for noiseless channel and also for noisy channel. Now, under noiseless channel, we have two protocols, simplest and stop and wait. And for noisy channel, we have stop and wait, automatic repeat request protocol, go back N ARQ protocol, selective repeat ARQ protocol. In this lecture, I'll be discussing about stop and wait ARQ protocol. Now, to understand the concept of stop and wait ARQ protocol, first I'll discuss stop and wait protocol, which is used for noiseless channel. Now, in stop and wait protocol, the sender sends one frame after getting a request from network layer and it waits for the feedback from the receiver. When the frame reaches the receiver, upon arrival of the receiver, upon arrival of the frame, the receiver sends the acknowledgement back to the sender. When the acknowledgement arrives, the sender understands that the transmission is complete, so it sends the next frame upon getting the request from the network layer. Now, again, upon receiving the frame, the receiver will send back the acknowledgement to complete the transmission. Now here we can see the design of stop and wait protocol. Here, the sender sends the data frame to the receiver after getting a request from network layer. The receiver will send back the acknowledgement frame to the sender. Now, we know that in practical, the noiseless channel cannot be realized. We always have a noisy channel in which the frame or the data tends to be corrupted, lost. So here we will study about the stop and wait automatic repeat request protocol, which is used for noisy channel. Now, error correction in stop and wait ARQ, it is achieved by keeping a copy of the transmitted frame and retransmitting the frame when the timer expires. In stop and wait ARQ, we use sequence number to number the frames. The sequence numbers are based on modulo 2 arithmetic. These sequence numbers are given to the frames to avoid the duplicate frames. The acknowledgement number is also given to the acknowledgement frame and it always announces in modulo 2 arithmetic the sequence number of the next frame expected. Now here we can see the design of the stop and wait automatic repeat request. Here the sender maintains a control variable Sn. Sn will point to the next frame to be sent. Whereas the receiver, it maintains a control variable Rn, which points to the sequence number, which represents the next frame, which is expected to be received. Now here we can see that the data frame, which is transmitted by the sender, it has a sequence number attached to it. Now, similarly, the receiver, when it transmits the acknowledgement upon arrival of the data frame, it has also acknowledgement number, acknowledgement frame. Now, here we can see three examples where stop and wait automatic repeat request protocol is used. In first example, we can see that the sender, it gets a request from the network layer, and here Sn is pointed to 0. That means the first frame which will be sent is frame 0. Here we can see that the Sn, it will increment it to 1 when this frame 0 will be received by the receiver and will also be acknowledged. Here the sender, it maintains a timeout period. This timeout period is equal to the round trip time period. That is the time taken by the frame to travel from sender to receiver and be processed there, and the time taken by the acknowledgement to propagate from receiver to the sender. Now, after the timeout period, this timer sets to go off. Now, here we can see that the frame 0 is sent by the sender. Now, this receiver will receive this frame 0. It will send back the acknowledgement with acknowledgement number 1. That means the next frame which the receiver is expected will be the frame number 1. So here we can see that Rn is incremented to 1. Now this acknowledgement frame is received by the sender, and after the sender receives this acknowledgement, it increments its pointer Sn to 1 and the transmission is complete. Now here we can see the second example that the sender is transmitting the frame 1. Now, due to the noisy channel, the frame 1 is lost. Now, the sender has the timer. This timeout period will be set off after the timer period is completed. Now here, when this sender will not receive the acknowledgement after the timeout period, it will retransmit this frame number 1 to the receiver and will restart the timeout period. Now, when this frame 1 will be received by the receiver, this receiver will acknowledge this frame 1, and here the acknowledgement frame will include the sequence number 0. That means the next frame which is expected by the receiver is frame number 0. So here we can see now Rn is incremented from 1 to 0. Now this acknowledgement number 0 is received by the sender and the transmission will be completed, and here Sn will be incremented to 0. That means the transmission of frame 1 is completed. Now, in third example, again, after getting request from the network layer, the sender will transmit the frame 0. Now, receiver will receive this frame 0. It will acknowledge this frame and will send back the acknowledgement frame with number 1. That means the next frame which is expected by the receiver is frame number 1. So here Rn it points to 1. Now, due to the noisy channel, the acknowledgement 1 is lost in between the channel between sender and the receiver. Now, after the timeout period, when the sender will not receive the acknowledgement, it will assume that the frame is lost or corrupted. So it will retransmit the frame 0. Now, upon receiving this frame 0, the sender, since it will discard this frame because this is the duplicate frame 0 which is received by the receiver. Now, it will send the acknowledgement number 1, which will be received by the sender, and the transmission for this frame will be complete, and this variable Sn will be incremented to the next number, which is 1. That means the next frame which will be transmitted by the sender will be now frame number 1. So here we can see that how the error control is achieved through stop and wait automatic repeat request, because here whenever the frame is not successfully received by the receiver, this frame is retransmitted by the sender to correct the transmission error. Now, what are the limitations of this stop and wait ARQ protocol? Although this protocol is easy to implement and it provides reliable communication, it has lower efficiency because the sender remains idle while waiting for the acknowledgement. Especially, it doesn't work properly in networks which have high delay. So, there is low channel utilization when we are using stop and wait ARQ protocol. This is all for today's lecture. Thank you.